Hi all, this is Santiago Garay, and I would like to start this tutorial number 1 of SkinDesigner. I like to start with simple panel creations and using these panels with a very simple workflow that I created to be able to quickly apply panels to surfaces, and a little bit of how to use certain things like layout functions to help us specify different areas for different panels. The focus is, though, in this tutorial is the creation of simple panel types, the ones that we are using. We end up using these types of components over here. Okay, so let's start from the beginning by dropping the SkinDesigner component. This is very important to start any script. Otherwise, we will have a warning each time we bring one of these components telling us to bring the SkinDesigner component. Otherwise, the script won't work. All right, so this is the panel component. Every panel starts from here, and I recommend when we are designing panels to use on this display section the SkinDesigner panel viewer. So the panel viewer basically will connect, will input the panel in it, and by specifying a point in the scene that we can specify right now and reference that point. So let's select that point first, and then we can reference that point and insert that in the location. The next thing we should do is apply a Boolean toggle to indicate that we want that to be drawn in the scene. Right now there's nothing showing because there's no input coming from the panel itself. The panel, to have any information coming out, we need to activate it. So another toggle by just connecting that in the activate will give us the panel default properties, which is simply a wall with some basic dimensions. Before we get into actually input our preferred dimensions, the first thing I recommend is having the name in a panel, whatever name you think makes sense to you, something that will differentiate from other panels, and something that you will use probably eventually to down the line on this workflow to refer to this specific panel. All right, so let's put some just overall dimensions, something like a slider could be one way to specify and play with the dimensions of your panels, and that's another way you could go and specify data. Would be something that is something I particularly prefer, is something on this kind of format, which which basically can be used in components throughout Grasshopper as well. That will end up in this is units and feet in this document, so 10 feet and 8 inches will be that dimension. Okay, just gonna go ahead and just apply, oops, sorry about that, apply some thickness to the panel of the wall as well. All right, so we have 3 dimensions. Gonna move this up a little bit, and now we can start plugging in some of these more specific data that comes from these components that we have here. The panel system, right now we have 2 options. We have a corner wall system and we have a wall system, which will represent a punch window and a wall kind of wall treatment. All right, so this point we have let's start plugging in this corner wall system, and there's maybe a lot of parameters here. but definitely there's all default values, and this is, you know, when we want to get more specific, there's more and more granularity on the detail of this panel, but we basically can just use default settings for this example, and you'll see by just looking at and plugging this in here how, you know, some mullions are being created around the panel. Okay, so at this point I will like to put some materials, and you see by the way how layers are being created. This layer SkinDesigner is the layer created by this panel viewer, and you know, these are the layers that you're creating as you apply properties to this. And so basically the idea is that, you know, we would have to apply some materials here to make sure we understand. I have already prepared a few simple materials to just understand the different elements of the panel. Okay, so that's a spandrel layer, spandrel glass layer, and then you can just have that as a surface in front of the wall. We can just apply a material there. All right, so at this point we can add a window in the window system input here, and there's only one window at this point, but this window you can just again plug it in right away, and you will define as, you know, default dimensions, which is pretty much half the panel width and half the panel height centered. Also, you'll notice that there are some mullions that are created around the window, and this is the default again treatment of that condition, but it can be overridden as well with the going deeper on these parameters on the corner wall system. All right, so we will put a material on the glass as well, so we can see at least the glass as a transparent surface. And now we can go ahead and apply some dimensions to our liking. One thing we can do here, I mean, we can apply a slider or values like we did on the panel, but also it's important to note that SkinDesigner has variables that they're quite useful. See, for instance, panel width is 1, and that will be basically, if you plug this here, it will match, the window will match always the width of the panel. Okay. Similarly, we could do on the height of the window something that goes on this format, for instance, panel height, and that would be something that we will multiply for instance, this is my new computer where I need to find this new key in this new keyword where the multiply symbol is, but I will get there. There we go. Sorry about that. So now we have the multiplication of a panel height. So basically you are saying, you know, let's do that height to 80% of the panel height. Okay, and we could actually go ahead and do something on the same line of, for instance, saying that the 20% would be the distance from bottom, right? So now we have that spandrel using the 20% of the panel, and the rest is the window. Okay, so with that, I think we already have a start of a simple panel that we can use and maybe start mapping it on a surface. All right, so now the first step to, you know, map this in a facade will be first create a facade, create a surface basically. So we can go ahead and do something, you know, that has some curved option, let's say something on this line. All right, and then the easier way to create a, you know, a SkinDesigner friendly surface is just extruding that curve, and we can go and map this to a, you know, let's go to something that has that height. And now the next step will be to create the, you know, bring the skin generator component, which is here in the construction section, which is in charge of mapping all these panels on the surface. All right, so a few parameters we need to add here first. First of all, I recommend using always these skin generator parameters, even though there's not always needed to use a lot of parameters here, but I would say just because you have to put a name, and that will be appropriate and good practice if we are if we want to have a name that makes sense, especially if you have different facades, different skin generators doing different parts of the building. This one will create a group layer like that one where all these panels are inside. Otherwise we'll create a very a funky name instead that you probably won't like. So I think with that we can just plug that into our skin parameters input, and then we would apply this panel. We have to just link or input in one of these panel bay inputs here, and you can have as many as you want. In this case we're just gonna start with one panel, and I think at this point, I think other than this, the surface itself is very important, of course. So without the surface we have nothing. So this is a B-rep reference. I would recommend that as well, to bring that geometry and link that to the skin surface list input. Now you'll see the last input is actually turn off this skin generator with another toggle, Boolean toggle. All right, so what happens is you will see how this works when we input it. See, only on the top panel, top row, this was generated, and not on the other rest of the surface, and that's because skin generator is trying to use that as a surface, but it's a solid, so it doesn't translate well if skin generator is in charge of that. So turning this off, I think basically remember when you do one of these extrusions, if it's capped, to delete those top and bottom caps. Okay, so just having the vertical vertical surfaces of the volume of that volume or that extrusion is what we need. Okay, there we go. So we have some panels applied here. Now we're going to turn off a few things like this preview of that surface, as well as we're gonna start turning off the surface of that facade, just seeing only the panels. Okay, by the way, I think we could change the size of this. It's a little bit on the small side for me, so I would go and scale this a little more like that, and you see, okay, that's how it updates. All right, that's still linked, so I'm gonna delete this guy here, but that gives us a better size of for facade to work with. Now we're gonna put layers and colors again to see what these panels actually should look like. I'm sorry, materials. So we have a glass surface again, and let's put some of this panel material. Now we see that how it reads. You can see a little bit of the pieces, how they connect together. All right, so that's a good start for this facade. All right, so at this point I show you one detail that I think is important to bring up, is that SkinDesigner by default it tries to keep the panel sizes consistent. So when you have a corner, instead of creating a special panel size, it will just wrap around just to keep that dimension of panels. So that means that your panels are all the same dimension everywhere. Now we can override that. If we want this to be a specific dimension, or it complete itself to that point, then you can use some of these skin generator parameters. There are a few of them, but in this case we want to use the one that says default skin chamfered corner. Okay, that's by default is true, so it looks like chamfered, but we will turn that to false, and you will see how that actually updates. There you go. So once we make that false, that now panel creates a custom size panel to complete that surface. All right, So with that, I think we can move to the next step, which will be, you know, create another panel so we can see how we can apply different panels in different areas. All right. So, before that, actually, I'd like to play with this other panel types so you see the differences of between the corner wall system and this wall system. So we can just basically switch between these two, and you see how the geometry is updating. In this case, is a new layer, is the clad layer to define that. The other thing that this wall system allows us to play with recess on the glass surface. So here we can actually, you know, specify something like half a foot of a recess on that glazing, and you see how the actual frame is adjusting to it. So it's always gonna adjust to your glazing location, that frame. Okay, so that gives us another aesthetics on that panel. Now we can go ahead and copy what we have here, at least a few things, and we're gonna reuse most of the parameters, but we're gonna create a new panel and rename this. It's very important to make sure that there are not equal names in the same skin generator. We could create some issues there, but in this case we're gonna add another element, and we will also look at this here using our panel viewer to see, you know, again, to help us get the right properties and the right dimensions of all this. So the shading system, we will go to that input on the panels. In this case, the louver will go and cover the entire surface of the panel. Now here we can also, I guess, we don't need that many inputs, and but yes, we will use a couple of things. Another Boolean toggle will be used to tell that actually it's not only in the entire panel is only on the window. So now we constrain our louver area to where the window is. The other thing is specifying I want to place that louver inside that window cavity. So we can offset that by moving by a dimension there, those louvers. Now we have them inside there, that cavity. All right, so now we have two panels. The second panel is ready to be connected. So we can just go ahead and connect that to the second input of the skin generator. And you can see how those panels are now placed next to each other all around the building, all right, on the surface. So at this point we could use, first, one thing I guess is important. Sometimes you don't want to use all the panels you have in your input here. So you can specify this, and we can have this as a checklist format. Say we can connect and tell with a list of numbers what panels we use. So we can have, in this case, again, in panel number 1, we can have both panels, or like have this one that is just panel 2 cover the entire surface. All right, so that's a list basically of integers that represent these numbers here. Now the next thing we want to do is find a way to apply it now in areas the other panel that we created, and for that task we have what we call the layout functions. Okay, the layout functions basically they take some type of data, and those are created by a number of different data functions that, you know, we have a few created, but this is something that we will expand. They are very simple, and, you know, basically it creates a sequence of numbers per each panel, which indicates what index or what ID will be used in each of these as it's generated. Okay, so you can create patterns, like in this case you can create random patterns as well, and but you know, basically in this case we're going to use just one. In this pattern will be one panel. So first we start connecting this data function to the layout function, and now to specify the panel that we want there, just going to copy this checklist and just select number 1, which is that a pattern of a list of just one number, and that is all we will need for now. So by connecting the design function to the design function input here, you see how now, because there's no specific location where we want this, is going everywhere. Now there's this input here in the layout function that allows to limit where to apply those, and we can use in this case a geometry or a number of geometry surfaces that are part of this facade, let's say, and matching this surface of the facade, area of the facade, and will limit those panels to that area. So how we can do that is it's quite a pretty straightforward process. One of the ways is just creating a solid back from that surface that we created ourselves in Rhino. Now we have a solid here. We can also have a B-rep or an object that we could create in the scene, and a Boolean intersection as well. So basically now we have to create, and we are going to do just create a layer for this objects that will be used to create these booleans. So if I can type this, the idea is to do a sphere. All right, so I'm gonna go this way, say somewhere here, and create one of these surfaces, and these spheres, and make sure they intersect our surface there, and that we can apply a ghosted material that I created just so we can see through as this object is moved around. So by referring to that, we reference that sphere, and now we have a Boolean that is an intersection, okay, of those two objects. So basically this is the, I'm gonna move this a little bit to the right to make this more legible, not as confusing. So we can plug now that intersection to those surfaces, and now you see that now only is bringing these glazed surfaces or panels on that area that is creating that intersection, and keeping the original panel specified in this case for the rest. All right, so, and of course this is something that we can play and do all kind of adjustments and transformations to kind of sculpt in a way this facade in any way we want. Okay, so we could do that and keep going and do another one here, for instance. It's very straightforward, I guess, to go ahead and now keep adding. It could be any object, any form, I guess, right? But it's just the same process of selecting this new object and creating a Boolean and then inserting it in the same input. So we're getting these other intersections to allow us to play with this kind of a sculpting of panel types in these surfaces. Okay. All right, so there's also another thing we quickly can create, I hope. Let's see. If I can create a new panel, and I can copy this panel, and I'm gonna detach all the materials, that all these inputs. We don't need any of this. Basically, this is a empty panel. Probably would have been easier to bring a panel from scratch. I was just trying to save my name information, the input there, and and but I guess, yeah, that would be at least the only thing I'm saving here, just being able to quickly type that name. And this, what I'm trying to do, it's a void, and there's this let's say API calls that you can do to this panel definition. So this input here allows us to create, basically to make API calls or function calls of the panels that not necessarily have a, we have a component for it, but this is a simple call that basically, if you see this now in this panel viewer, it's just a wall, but if we don't want that wall, we can turn this off by inputting that call in the definitions input here. So basically it's an empty panel, okay? And that is useful, for instance, and we're gonna turn off this. If we wanna connect this as a third here, and now we could have another of this surfaces, of this, these data functions and layout functions. If I can specify their number, so the third panel, and say instead of connecting this to the same input here, this will be only one or the other. All right, so this surface only will be, which is this one here, will be bringing that panel, okay, and only the other one is bringing the panel number 1. So let's separate this a little bit to be less confusing. Now we're using the same original surface for both, okay, so that's fine. All right, so we can connect multiple design functions so as well, so we can just add this one. If I can zoom in and see this clearly, where it goes there. So I'm adding that input, okay, to the design functions input on the skin generator. All right, so I think if everything goes well, I should turn this on and start having two different panels. See, now we have this one that actually could be useful, especially if your surfaces are not finishing as a straight line, and all your facades are not completely and in a horizontal shape, let's say, right? If it's not flat, so you could create another sculpting of those facades using empty or void panels. Okay, so now I'm just gonna select very quickly to finish. I'm gonna select these 3 objects, and just to show how we can still manipulate everything very quickly, and for instance and things still hold up probably. Like in this case, if we scale these objects, everything will still work, so we still have the same workflow and the same solution being generated with just more panels and a larger surface. Okay, so this allows you to very quickly make a lot of changes of any kind through the entire workflow, and quickly get iteratively a solution. All right, so I don't want to go in depth with more of these layout functions or the skin generator. We're going to have another tutorial that will focus on those specifically. Here is more I guess to give you this initial workflow for how to generate simple panels and how to see them as you work and create them, and then how you can apply them very quickly just to see them in a larger area. Okay, so this hopefully is good and useful enough for you guys to keep playing with it, and try your own workflows with this, and hopefully come up with really cool facade designs. And I'd like to hear from you guys if you have comments, questions, or issues with this specific workflow, all right, or any other things that are being shown here with SkinDesigner. Okay, so I'm happy to respond that in the Grasshopper 3D forum. if you post the questions there. All right, so we'll see you, I guess, in the tutorial number 2, and thank you for listening. Bye.